Morning Year 11. Today we're going to look at the process of cracking. So hopefully you've had a chance to look at the do now questions before you've watched this DI. If not, pause the video, have a go at the do now. Okay, so question 1 asked us what is crude oil, and all we need to do is say that crude oil is a mixture of hydrocarbons. A hydrocarbon is a compound that contains hydrogen and carbon only. Question 3 asks, describe what happens to flammability and energy released when burned as carbon chain length increases. So as we saw last lesson, if we increase the chain length, the flammability decreases, it's harder to set on fire, whereas the energy released when burned increases as carbon chain length increases. Question 4 asks what makes a good fuel, and it makes a good fuel if a lot of energy is released when it's burned and it is easy to set on fire, so its ignition is high. 5, which fraction would make the best fuel, fuel oil or petrol? Say why. For this one, the correct answer is petrol because it is easy to ignite. It also has a low viscosity, which means it's easy to transport. Fuel oil may well give out more energy when burned, but it would burn with a lot of smoke and soot and uncombusted hydrocarbons. So let's move on to the direct instruction. So as we mentioned previously, we're looking at the idea of cracking, which is the splitting of less useful longer chain hydrocarbons into shorter, more useful fractions by heating in the presence of a catalyst. And I'm going to start off by discussing this graph here. So this tells us why we have to carry out cracking. So if we look at this solid line here, this tells us what sort of hydrocarbons you get in your crude oil. And as you can tell from the graph, the most common chain length hydrocarbon in crude oil is around 17 to 20 carbon. So that's quite a long hydrocarbon. If we have a look at the next part of the graph, the dotted line, this tells us what we actually want. So we want lots of carbons with a length of 5 to 8 molecules. We want quite a few 13 to 16s. This bit here kind of relates to petrol, and this might relate to fuel oil or diesel. So we've got a problem. We want lots of these, but we have lots of these, and to deal with that problem we do this process called cracking. So we're going to split long chain hydrocarbons into shorter ones, and we do that by heating it in the presence of the catalyst. So over here we're going into a little bit more detail than we need. There's kind of two ways to approach it. We can heat it to about 550 degrees with a catalyst present. Sometimes we say it's called a zeolite, which has got aluminium oxide and silicon oxide. Or a more straightforward one is to do it with steam. We need a higher temperature, it needs to get up to 800 degrees, but we don't actually, the steam acts as the catalyst. So this one, you don't need any extra catalyst. As far as we're concerned though, if it asks us about it in the exam, all we have to do is say it's heated in the presence of a catalyst. So this is the key bit that we need to know. This reaction here, or these displayed formulae, show us what's going on. We start off with a long chain hydrocarbon. So in this reaction, we have 1, 2, 3, 4, 5, 6 carbons. Hence, it's called hexane, and you'll notice it's an alkane. It's saturated, which means it has no double bonds. So when we heat this in the presence of our catalyst, it undergoes a process called thermal decomposition, which is when something breaks into smaller compounds when it's heated. It breaks into an alkane and an alkene. In this instance, it's butane, so it's got 4 carbons. We'd need to be able to name that. And the alkene, so note the ENE on the end of alkene matching the ENE on the end of ethene. This has something that alkanes do not. So all alkenes must have a double bond. So alkenes have got to have that double bond. we say if it has a double bond, it is unsaturated. So we say it's unsaturated. If we go down here, we've got another example of cracking. So this is something that you might have to do. You get given the alkane that is being split apart in the first place. You might get given the formula for the alkene. In this instance, it's got 2 carbons, so many evil. So if we use the rhyme that or the mnemonic we learned a few days ago, that's got to be ethene, just like the one above. So our ethene, and we need to figure out how many carbons we've got left from our decane. So we had 10 to start with. Ethene contains 2. So whatever we're making on this side has to have 8 carbons. Next we'll have a look at the hydrogens. So this this molecule has 22 hydrogens, and we've got 4 over here. So 22 minus 4 gives me 18. So this is good. This works for me because I know this must be an alkane, because it fits with the general formula for alkanes, which is CnH2n plus 2. So this is definitely an alkane. So remember, an alkane is saturated, it has no double bonds, whereas an alkene is unsaturated, it has 1 double bond. You might also be asked how we would test to see if an alkene is present. This test is relatively simple, so all you'd have to do is add bromine water to your compound. If an alkene is present, so the positive test for an alkene is that the bromine water goes from orangey brown to colourless. We cannot say clear, we have to say colourless. The reason this happens is that the bromine breaks this double bond, and you end up with bromine taking the place of the hydrogen. You end up with bromine joining this molecule as part of it, so it goes from orange to colourless. For your first activity, you're going to need to have a go at these questions and use the direct instruction to help you. And task 2 is the sort of question you might come across in an exam. And it's asking us to describe the process of cracking shown in the diagram. And we've got some pointers to help us make sure we hit all the points. We need to talk about the fact that the decane, which is the alkane in the boiling tube at the start, so we would heat that up. We need to say that it's going to evaporate, it's going to reach a high temperature, and it's going to pass over this broken pottery, and this broken pottery is going to act as our catalyst. As it passes over the catalyst, it's going to be cracked, it's going to undergo that thermal decomposition, and it's going to form octane, and it's going to form ethene. We'll also have to talk about why the octane condenses here, whereas the ethene doesn't condense at all. It's still a gas when it gets to this test tube.